Day 324 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 377, combination sum 4. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. Now, before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description and get you some. Now, let's see what the question says. Given an array of distinct integers nums and a target integer target, return the number of possible combinations that add up to target. The test cases are generated so that the answer can fit into a 32-bit integer. All right, y'all, that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 2, and 3. The target is 4, the output is 7. So what we want to do is we want to count how many ways we can take these integers right here and add different create different combinations so that we can add up these elements to equal the target, which is 4. So the explanation gives us a list of those 7 different combinations. So let's go through them. It says the possible combination ways are 1 plus 1 plus 1 plus 1. So we could just add 1 4 times and that will get us our target of 4. We could do 1 plus 1 plus 2, which uses these two elements right here, and that will get us our target 4. We could do 1 plus 2 plus 1, which will get which uses these two elements, which will get us a target of 4. We can do 1 plus 3, which is 1 here and a 3 here. We can do 2 plus 1 plus 1, which is these two elements right here equals 4. We could do 2 plus 2, that equals 4, and we could do 3 plus 1, that equals 4 as well. And it says, note that different sequences are counted as different combinations, which is important to remember because on previous problems like this, that was not the case. But as you can see here, we have a 1 plus 1 plus 2 equals 4. Then right here we have a 2 plus 1 plus 1 equals 4. Then we have a 1 plus 2 plus 1 equals 4. These are all using the same elements, but they're different combinations of, or a different order of these elements. And we have to count each one of these orders or each one of these combinations, right, as a different combination. So as you can see, we can use each number as much as we want, right? We can use the 1 4 times if we want to. We can use the 2 2 times if we want to. So it's not we don't have a restriction when it comes to how many times we can use each number, and we want to return all of the possible combinations. And in this case, it's 7. And these are the possible combinations. So let's look at example 2 where it's impossible to reach the target, right? So in example 2, we have the input nums equals 9, target equals 3. This time the output is 0 because it's impossible for us to take this one number right here and make it equal to 3. There's nothing we can do to do that, so we're just going to return an output of 0. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult either, so let's get into it. Now, first thing we need to do is we're going to need to create a helper function to compute the number of combinations for the given target. This helper function is it's gonna involve some recursion as well, so I hope you're excited about that. Now, to create this function, we could just say func. We could call it helper, open up the parentheses, excuse me. We're going to say underscore nums, colon, that's going to be an array of integers. So we're going to say square bracket, int, boom. Come outside that square bracket, we're going to say comma, underscore, then we're going to say target, colon, and target is going to be just a regular integer. Then we're going to say comma, then we're going to say underscore, then we're going to say dict, short for dictionary, then we're going to say colon. Now dict is going to be in out, so we're going to type in out. We're going to open up the square brackets. We're going to say int colon int, so it's going to be a dictionary of integers, just like that. Then we're going to come outside of this parentheses and it's going to return, so we're going to say dash greater than sign, and it's going to be an integer as well, so it's going to return an integer. Now we need to see if the target becomes negative, and that means no valid combination exists. So we can just say if target is less than 0, then we could just open up the brackets and we could return 0, because that means there's no combinations that exist. Boom. Then we come right here, and if the result is already computed, then we need to return it. So we can say if let saved equals dict, open up the square brackets, target, boom. Then we could just come outside of that and we could say return saved, just like that. Now if the result is now we need a variable to that's going to keep track of the number of valid combinations. So in order to do that, we could just declare a variable. We could say result and set that equal to 0. Then now we need to iterate over each number in the array. And to do that, we could just say for num in nums, just like that. And we're going to use some recursive to find the combinations for the target minus num. So in order to do that, we'll say result plus equals helper, open up the parentheses, we're going to say nums, comma, target, comma, target minus num, comma, and dict. So once again, when we take the target, say we take the target and we subtract the 2, that lets us know how many or what is the next element that we'll need to create the target, right? So if we take target and subtract it by 2, now we know we need another 2 to equal 4. Now we need to store all the computed results in the dictionary for future use. So in order to do that, we come right here and we can say, it should be a T right here, but we could come right here to store the computer result. We could just say dict, open up the square brackets, target, come outside those square brackets, say equals result, just like that. Then we could just return the computed number of ways by saying return result, just like that. But we're not done yet, because that is just the helper function. We still need to write this in the main function. So for the main function, we need a dictionary to store the computed results. So we're just going to declare a variable, call it dict, and we can set that equal to an array of integers. So square bracket int colon int, just like that, and come outside of the square brackets and put parentheses to initialize it. Then we need a base case, and there's one way to form the sum 0. So we could say dict square bracket 0. We could just set that equal to 1. Boom. Then we need to call our helper function, and that's going to help us to compute the result. So we could just say return helper, open up the parentheses, pass in nums, pass in comma target, comma, and dict. So for all in and out parameters, we have to put this and sign right here. So that's why the and sign is right there. So now let's go ahead and give it a run. Make sure this runs like it's supposed to. Ooh, okay. So what does it say? Let me see, y'all. Sorry. Let's see. Oh, it shouldn't be a space in between those. So let's go ahead and run this again. See if it runs. Ooh, and it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. See what that time looking like. Okay, 4 milliseconds beats 53.49% of users with Swift, y'all. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that. So make sure y'all read it, go over it, learn it, love it, y'all. Get one more look at it. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.